This lecture is some examples of doubly reinforced section analysis. We'll start with our beam. This beam has two number 4s in the tension position with with the cover of 2 inches. It has 3 number 7s at the base, cover again 2 inches. The depth of the beam is 24 inches. The width of the beam is 8. F prime C is equal to 4 kips per square inch. F sub y is 60 kips per square inch. So we're going to perform this analysis. First thing that we should do is collect our terms. So D is equal to H minus the cover, which is 24 minus 2, which is 22 inches. D prime is 2 inches. I can read that off the drawing. B is equal to 8 inches. That's the width of the beam. A sub S is equal to 3 number 7s. 3 number 7s is 3 times 0.60, which is 1.8 square inches. A prime S, 2 number 4s, 0.4 square inches. And I think that's what we need. So we can now do our analysis. The first thing we do is we compute rho and rho prime. Rho is equal to AS divided by BD, which is equal to 3 number 9s. Good God, Kevin. So this is actually 1, and this is 3 square inches, is equal to 3 divided by 8 times 22, which is 0.017. Rho prime is equal to 0.4 divided by 8 times 22, and that is 0.0022. Rho minus rho prime is 0.017 less 0.022, and that is equal to 0.0148. K is equal to 0.85 beta 1 F prime C over F sub y, D prime over D by 87 divided by 87 minus F sub y, and that is equal to 0.0141. Rho minus rho prime is greater than K, which means the tension steel yields. Rho minus rho prime is less than rho max, right? Because rho max for 4,000 psi concrete, 60 ksi steel is equal to 0.01806. So that is good. And if that is true, and the tension steel yields, then F sub S in compression is F sub Y. From there, we can compute our value for A, where A is equal to AS minus A prime S, F sub Y, divided by 0.85 F prime C B, which is equal to 3 minus 0.4, multiplied by 60, and divided by 0.85. F prime C is 4, B is equal to 8, and this gives me a value for A, which is equal to 5.76 inches. That's the depth of the Whitney compression block. We know that C is equal to A divided by beta 1. So C is equal to 5.76 divided by 0.85. That is 6.77 inches. The nominal moment capacity is equal to A(s) minus A prime S, F sub y, D minus A over 2, plus A prime of S, F sub y, D minus D prime. This is equal to 3 minus 0.4 multiplied by 60 multiplied by D minus A over 2, so D is 22 minus 2 plus 0.4 multiplied by 60 multiplied by 22 minus 2, and of course this is A is not 2, A is, god damn it, 2 minus 5.76 over 2, and if we go through that calculation, we'll find that's 3,323.73 kip inches. Multiply that by 1 foot over 12 inches. That is equal to 276.98 kip feet. M sub U is equal to phi M sub N. Phi is equal to 0.9, if you remember, because rho minus rho prime is less than rho max. So this is equal to, M sub U is equal to 0.9 multiplied by 276.98, and that comes out to be 249.28, and we would call that 249 kip feet. And that's how we do a problem when everything is behaving fairly well. Let's do another one. In our next problem, we're going to look at what happens when we have a different beam. So let's take a look specifically at this different beam. We have a beam here. It has 2 inches cover on 2 number 5s. Beam width is 8 inches. Beam depth is 24 inches. The tension reinforcement is 2 number 9s. Our cover is 2 inches. First thing we need to do, we're going to look at all of our terms. A sub S is equal to 2 number 9, so 2 multiplied by 1 square inch is 2 inches squared. A prime sub S, excuse me, is 2 number 5s. 2 number 5s is 0.62 square inches. F prime C is equal to 4 kips per square inch. F sub y is equal to 60 kips per square inch. And from there we can calculate our values, right? Rho is equal to AS over BD, which is equal to 2 inches squared divided by BD, and that comes out to be 0.0113. Rho prime is A prime S over BD, and if we carry out that equation, rho prime is equal to 0.62 divided by 8 multiplied by 22, that is equal to 0.0035. K is still equal to 0.85 beta 1, f prime c over f sub y, d prime over d, 87 divided by 87 minus f sub y. If we plug those values in, beta 1 is 0.85. Again, you can look that up in the handout that will be present along with the examination, but it'll always be 0.85 for 4 kips per square inch concrete and 60 kips per square inch yield strength steel. D prime is 2, D is 22, and this is 87 divided by 87 minus 60. That comes out to be 0.0141. Rho minus rho prime is 0.0113 less 0.0035, and that comes out to be 0.0078. Rho minus rho prime is less than K. When rho minus rho prime is less than K, the compression steel does not yield. The consequence of the compression strength, steel not yielding, is that F prime sub S is less than F sub Y. We need to use our quadratic formula to solve for C. Remember, we have an equation A1C squared plus A2C plus A3 is equal to 0. A1 is 0.85 beta 1 F prime C B. A2 is A prime S multiplied by 87 minus 0.85 F prime C A prime S minus A sub S F sub Y, and A3 is equal to negative 87 A prime S D prime. Right? C is equal to negative B plus or minus the square root B squared minus 4AC all over 2A. A1, which is A, is equal to 0.85 multiplied by 0.85 multiplied by 4 multiplied by 8. That is equal to 23.1. A2 is equal to 0.61 multiplied by 87 minus 0.85 multiplied by 4. Now, what we've done here is we've factored the A prime S out on both sides, minus A sub S F sub Y. That is negative 69.0. A3 is equal to negative 87 multiplied by 0.61 multiplied by 2, which is negative 106.14. If I put that into my numbers, and you can see them here, as we go through that calculation, we will come up with the conclusion that C is equal to 4.106 inches. Once we know that, we can continue our calculation. C is equal to 4.106. Just a second. That I think is, yes, 4.106. C is equal to 4.106. For some reason I was thinking the number was smaller. F prime S, the strain or the stress in the tension or the compression steel, F prime S, the stress, the compression steel, is equal to 87 multiplied by C minus D prime over C, which is equal to 87 multiplied by 4.106 minus 2, all divided by 4.106, and that is equal to 44.1 0.623. Good. Steel does not yield just like we said it would. This is a check to make sure that we had not made any calculations, and that F prime S is in fact less than F sub Y. We could also check this by using our expression for the tension the strain in the tension reinforcement, as is 0.003 D minus C over C, and that will come out to be 0.0131, which is greater than 0.005, so that's good. Rho minus rho prime is also less than rho max. If you recall, when we did the calculation, rho minus rho prime is 0.0078. That's very much smaller than rho max. That being the case, the tension steel is yielding. We know the values for our reinforcement, and we can calculate from there our nominal moment. Our nominal